Hello and welcome back to another episode of Excel Statistics. Today we will be talking about three-group hypothesis testing using ANOVA. Previously we have talked about single group and two-group hypothesis testing, and now we're moving on to three or more. ANOVA can actually be used for any number of groups of data. So here we have just a very small data set. We've got three doctors and four random samples of their cost of care for a specific operation. So what we want to know is there a difference in the cost of care between the three doctors? For that, we will be using our ANOVA analysis. Like our other hypothesis testing, we have to start off with our hypotheses. So we will have both a null and an alternative hypothesis. For both of these, we will consider the null to be true unless proven otherwise. So here we are going to say our null that our means are equal. An alternative is that our means are not equal. So now that we have our hypotheses set up, we will go over our data tab, our data analysis tool pack, and we will be looking for ANOVA single factor. You will notice there are two other options here, ANOVA two-factor with replication and without replication. Those will allow you to extend the ANOVA analysis beyond a single factor here, which is the cost of care of a single procedure, to where you could look at this as the cost of care over multiple different procedures as well. We'll select our ANOVA single factor and just a couple inputs here. We have our input range. I'll select my entire data set. It is grouped in columns and I do have labels in the first row. Again, we have our alpha value of 0.05, which will give us a 95% confidence results. So our output range, I will select right here below my hypotheses. We'll let that come out. So we notice here our ANOVA single factor, we start with our summary data. So for each one of our doctors, Bob, Don, and Ron, we had 4 records. We have their sum, their average, variance. Now if we look down here at our ANOVA table, where we find the data we're most interested in, we're going to concentrate here in our between groups section, where we have data for sum of the squares of the errors, degrees of freedom, the mean squared error, and then we have our F value and our F critical. Now for these, we are going to compare these similar to what we did for our two-group hypothesis test, in that if the absolute value of our F is greater than our F critical, which is our rejection point, then we will assume our null value or null hypothesis is incorrect and we will reject that, which is the case here. So because our absolute value of F is greater than F crit, we reject our null. So that means we will assume our means are not equal. Now, unfortunately, at this point, if we wanted to determine which means were different than the others, we would need to go back to our two-group hypothesis testing and perform tests on Bob versus Don, Don versus Ron, and Bob versus Ron in order to figure out which ones are different. However, had we come to the opposite conclusion, where we accepted our null hypothesis, we could complete our test and be done. That's really all there is to ANOVA testing, the very simple basics of how to perform the test. Hopefully you found this video useful, and thank you for watching.